All right, so this question is about probabilities, and although they are saying without replacement, but it's not really indicative of anything there, right? So let's start with a small review about probabilities. So I'm going to start with the Venn diagram. So suppose we have a Venn diagram, and let's say we have an event E inside, that's the red one, and we have the universal set over here, right? So the probability of E, of any event, all right, will be how many elements are in E, all right? So the number of elements in E divided by the number of elements into the universal set, all right? So this is the general formula, basically. As an illustration, so suppose I have 5 here inside the E. I have 20 over here. All right. So the number of elements in E is going to be 5, and the number of elements into the box is going to be 5 plus 20. Right. So it's going to be 25. So this is basically the probability. I'm not reducing, but that gives you the idea. Now, actually, there is another part to this as well, because we're going to be using the counting principles. So the counting principles here, after reading the problem, is there are some keywords, right? So the keywords here is choose, basically. All right. So every time you are choosing a number from another number, usually you are using combination. All right, so I say usually here because you need to verify something really important. Combination works always with whenever the order is not important. All right, so this is equivalent to order not important, and this is always depending from your understanding to the problem. All right, so let's go to the problem right now. So what we have, by the way, we need to identify always the event, the universal set, and how many elements in order to get the probabilities, right? So let's go to the problem. So what we have here, we have 10 bottles of soda and 9 bottles of water in the cooler, right? So let's suppose this is my cooler here, and I have the soda bottles here. So we have 10 bottles of soda, and we have 9 bottles of water, right? Okay, so now the universal set, you are literally choosing 14 bottles, all right, at random from here. All right, so that's what is the universal set. So your universal set is you choose or select, all right, 14 bottles, or all right, 14 items out of how many? It's going to be 19 items. All right, the 19 items, they are the 10 bottles of soda and the 10 bottles of water, right? So whenever you add them up, you're going to be 19. Now, this is the description of my universal set. If I'm looking for the how many elements into the universal set, all right, so the selection here, they did not tell you, all right, the content of this, you are bringing the soda to your friends, and you are not selecting who's first, who's second, who's third. So basically, you are bringing the 14 bottles and put them on the table, and they're gonna serve themselves. So the order really is not important. Who's gonna be taken what later on is their own problems. Your problem is to select the 14 bottles and put them on the table, basically, right? So this is basically the context of the problem. Therefore, we are doing combination here, and this is going to be C. Out of 19, we're going to select 14. All right, so this we're going to let it for the calculator later on. Okay, now going back to the event E. So the event E is actually you are choosing 8 sodas and 6 waters. So 8 sodas, it means you are selecting 8 out of how many? So if you are selecting 8, how many bottles of soda we have? We have 10. So you are selecting 8 out of 10 sodas, and you are selecting 6 words, right? So this is the end statement here, all right? So you're gonna select 6 words out of how many? 9 bottles, all right? All right, so this statement is gonna be a combination of 10, all right? Out of 10, you're gonna select 8, all right? This statement here is going to be another combination, 9 for the N and 6 for the R, all right? And the AND, this statement AND is a multiplication. So on probability, usually the AND statement represents multiplication. And again, this is the number of element in E, all right? So we're going to do this with the calculator as well. All right, so I hope you are with me here. So again, we're gonna let everything to the calculator. So let's try to do the combination calculator. So the combination, in order to access the combination, you need to go to math, and then you go to probability, and then you have on number 3, that's NCR, which is the combination, right? Okay, so let's start this. So if I want to do C1914, I have to type 19 first, and then I go to math and go to probability. I'm going to go to the left because probability is right here toward the end. So if I go left, I go right away to the probability. And then I scroll down to number 3 and enter and put 14 here, right? And let's see, so that's going to be 11,628. So this number is 11,628. And I'm going to do right now the E. So for E, going to be starting again with 10 first. And then I'm going to go math, left, go to probability, and then combination, number 3. And then you're gonna put 8 after that, and then I'm not going to calculate it right away. I'm gonna multiply it right now by 9. All right, math, probability, combination, enter, and then put 6. So now that the multiplication already done, I'm gonna put enter, and that's gonna be 3,780. So if I'm going to be using the Venn diagram from before, I can delete the numbers here. All right. So this would be for the E, it's 3,780. However, I cannot put the 11,000 inside, so I'm going to put it outside. Is 11,628. All right. Like that, they don't add up. So this is going to be the probability divided by 11,628, and on top numerator is going to be 3,780. So do the calculation, and what I can do, I can highlight this one, enter, and then divide, and go with the arrow, and highlight the 11,000, enter right now, and enter again. So you're going to be 0.3250. All right, so I don't know how many digits you have to round it. They are saying 3 decimal places. So this is going to be 0.325. And that's all.